Okay, let's continue chapter 10. We talked about last time. We talked about the estimation using GARCH model and exponentially weighted moving average. Okay, the first I wanted to introduce you the GARCH model. Okay, so so what is GARCH model? So the GARCH typically we did this one. So remember, so we did the return. Okay, the log return is the log of the price of the current price minus the log of the previous day's price, or you're using log.
We can't see your screen.
Oh, you cannot see it? Okay, I will try to make it bigger. Is that good?
Correct.
No, we just can't see it at all.
Oh, you can. Okay, let me see. I think I need to share my screen. Okay, okay, one moment. Okay, sorry, I think I need to click on the share screen. Yeah, is that good?
Yes.
Okay, so we have the loan return. Last time we talked about, and also we have a volatility. So the volatility, when you do the loan return, you just take the square that loan return, and so that's we talk about. Okay, so we can go back to see what we did last time. Okay. The last time we remember, so we have to take the variance, so we just square the daily return. Okay, square the daily return, so we take the variance, consider it to be the measure of the volatility. Okay, and so the loan return is going to be ln of the relative price. Okay, this is a P3, which is a most recent price, and then divided by the previous day's price. You take the deviation and take the ln of that deviation. Okay, the ln of deviation is going to be the return. Okay. So we have the return and variance or standard deviation. Okay, so what is that? Most important thing is that when we introduce the GARCH model is going to be okay. So why we introduce the GARCH model is first you see this one is the first we code is ARCH. Okay, the ARCH model is autoregressive conditional heteroscedasticity. Okay, the ARCH model was first introduced by Robert Engel in 1982. So what his contribution is that you can see the volatility, okay, here is associated or related to the previous return. So there's it's a x squared t minus 1, t minus p. So they give different weight, okay, different weight, and then that's the sum of the previous day's return squared. Okay, so how you assign the weight. Okay, last time we remember, so we're using the method is called maximization likelihood. So it's going to maximize the likelihood method. So they give different weight. Typically, the weight is going to be more recent day will have more impact or influence on the volatility. Okay, for example, the stock volatility today. Okay, the return of yesterday has more weight, so you're gonna put more weight on the return of the yesterday, or more weight on the return of the weeks before, rather than the weight in a month ago. So that's what is this GARCH model talking about. So the major contribution of Robert Engel is that the stock volatility is related to the previous day's stock return. Okay, any questions? Good. Okay, so basically that's the formula tells us about, sometimes students hate that, it's going to why you put this equation and formula, what that means. Okay, basically that's how you interpret, how you understand this GARCH model. And okay, so Boleslav in 1986, okay, and extend the GARCH model. And so what his contribution is that allow that volatility or the variance have an additional autoregressive structure within itself. So now we generalized the GARCH model is called GARCH model. So the GARCH model is the current stock volatility is not only associated with the previous day's stock return, okay, squared, but also is associated with the stock's previous variance. Okay, you see they add this part, okay, this part. So what that means, it meaning is that the stock volatility is more volatile. Basically, it's not just happened today. So the stock tend to be volatile in history. Okay, so we sometimes we using this one in finance. It's kind of like a momentum. So momentum. So is this stock, is very volatile, and it's gonna last for a while. Okay, so typically they Boleslav and add this part, okay, to code this GARCH model. The GARCH model is the stock volatility is only affected by the stock return in the past, but also is associated with the stock's volatility of itself in the past. So that's a GARCH model. So the GARCH model could be the lagged, okay, could be like a P and a Q. So the different lags, okay, like say the impact could come from several days ago. It could come from several days ago, but most of the time, so we see this one is pretty complex. So we have the GARCH model P and the Q, lag the P times P or Q, different lag. But in particular, so we wanted to simplify is that using simpler is called GARCH 1.1. So the GARCH 1.1 is that they only lagged one time period. So the current stock volatility is only affected by previous days stock return. and the previous day's volatility. So they elect only one time. So it does not considering the effect from previous week, previous month, or something like that. Okay, only the 1 day, okay, likely to in the past. Okay, now we have, now we go back to the course content. So we did last time. So it goes to the course content.
I think they're only allowed 10 people in the store.
Huh? Only 10 people? What?
No, 10.
16 participants? Yeah. Okay, so yeah, we have 16. Okay, so let's see, we have week 12. Okay, let's go to the course content. We need to download the file we worked on last time. Okay, this is table 10.4. Yeah, please download that file. Okay, so 10.4, we it's okay. Okay, so so you need to get to your okay. Okay, we work on the SP 500 index. This is the data we have. So you get the data, which is a 10.4. That's where you got the data from. Okay. Good. Any questions? Okay, to estimate using the GARCH 11 model, this is the date and the price, SP 500. And first you calculate return. Okay, the return is going to be the most recent price minus previous day's price and divided by previous day. Okay, this is a return. And then you calculate variance. Okay, so the variance, remember, so you're gonna take 1 lax or lose 1 degree of freedom. Okay, this one variance, the first one you square this one. Okay, the D4, which is the return, you square that. And the second one is not going to square that, okay? And second, you have to use the GARCH 1 formula. Okay, this is the GARCH 11 formula. Okay, GARCH 11 formula. And so this going to be, we have, okay, you see, C $1283, 1284, and 1285. Okay, all those 3 cells. Okay, so this is the parameter we're gonna estimate. Okay, so we go all the way down. C, you can see. Okay, this is C. 1283, C1284, and 1285. Okay, these are the 3 parameters. Okay, the 3 parameters we call them omega and beta and alpha. Okay, omega, alpha, and beta. So all those are 3 parameters. So we have all these 3 parameters, and then you see this is omega, and this alpha and beta. So you apply that formula you see the E5, which is the return of the variance of the previous day's variance. Okay, this is E5. And the D5 is the previous day's return. Okay, the previous day's return. So you have the weight, given the weight is alpha and beta. And the first part is called the long run variance. So you apply that formula. Okay, it's very important. You make sure this formula is correct, and then you drag all the way down. Okay, so you apply that formula. Okay, so when you have that, and then you have you estimate, right? You estimate the volatility. Okay, the volatility is going to be the square root of the variance. Okay, if you times 100, that means you change it to percent. Okay, change it to percent. So that's the volatility of the variance. Okay, you apply that formula and drag it all the way down. That's a volatility. Okay. So any questions? Okay, so we go down all the way and we can see this is the parameter you estimate. Okay, so when you estimate that parameter, so we have this one. This is a U times is 10,000. Okay, that's gonna be this number. Okay, so and then this beta is the same. This is a 0.1. This is a, you see the alpha, we using that number times 0.1 is because we give different weight. Okay. So when you go back to check that, is that you, when you using the solver research over that, which is, this is gonna, which is omega, the B, the 1283, which is the omega times 100,000. Okay, we do not want this one to be date, so we're using just a general. Okay, so we have this one. This is a 10,000, so which is omega times the 10,000, and for the beta, so the beta is going to be 0.1 exactly the same, so it's only times only 1, but for the alpha, you have to times 10. Okay, that's how you estimate alpha, which is going to be the estimate number minus 0.08, right? So that's alpha. Okay, so next step that we talk about is we have this one, which is the GARCH model is that you have the alpha and the beta and the gamma equal to 1. Okay, so when you estimate that, okay, the gamma, what is the gamma? The gamma is, we have the alpha and the beta right there, and the gamma is 1 minus alpha and the beta. So you can see the gamma basically is the coefficient or the weight assigned to the long run variance. Okay, this is a this is a long run variance. So in the GARCH 1.1 model, is you see the volatility is omega, okay, plus alpha, which is the coefficient of the return. Okay, the mu is the square is a return. The beta is the variance of itself. Okay, previous variance. Okay, we lack only one leg. That's why the GARCH 1.1. Okay, so alpha and beta. So the beta give a heavier weight based on the previous day variance. Okay, the alpha is lower, it gives lower weight of the previous day's return. Okay, so what is the omega? So omega is the gamma times the long run variance. Okay, so long run variance. So basically, that's how we interpret the result and why we do that. Okay, so when you have that, the common GARCH model, so we're gonna estimate the likelihood. Okay, so remember the long run variance. Okay, the variance. Okay, this one. Okay, this is the return squared minus. Okay, we have the return squared, previously squared, divided by the E5, which is the variance. So we do that based on the PowerPoint slides we have. Okay, so we choose parameters that maximize the sum of the ln, the variance. Okay, this is new, minus the mu squared divided by mu nu is going to be, this is how the function or the formula we used for the likelihood. Okay, for the likelihood. So, and you sum them up. Okay, so what we do is that you sum them up. So you sum all the likelihood, and this number is we highlighted right here. This is the sum of a likelihood. Okay, and then you have data. Okay, you choose a solver. If you don't have a solver, you need to go file option. Okay, option, and you go add in, and then you Excel add in, you click on go, and then you choose analysis pack and the solver right here, solver add in, and you click on OK. And then you have this button right here. Otherwise, you don't have this button. So you cannot use solver if you didn't add this function. Okay, so click on solver. Okay, so the first you set objectives. This is one. Okay, so object is this. Okay, and you wanted to maximize that. Okay, maximize that by changing. Okay, remember, so this alpha, omega, beta, the different times that we change this numbers. Okay, changing all these 3 numbers. Okay, so we maximize this by changing all these 3 numbers. Okay, so this is the area or the variables you might want to change. Okay, so for example, you can type in those numbers and then you set the constraint. So the first one is omega, and you have to be positive, right? You cannot assign a weight which is a negative. It has to be positive. And then the cell, this one, 1284, okay, is positive, okay, greater than 0, less than 1. And yes, that's all this, the weight you assigned supposed to be up to 100%, so you cannot over 100%. Okay. Set this constraint, how you are subject to the constraint, you just add something. You say add this cell equal or greater and the constraint, and then you add. Okay. So I already added right here. And then you click on solver and it will change. Okay, so let's see how the number is going to change. So basically, you can set this number, whatever number you want. Okay, like a 0.2, 0.2. Okay, this is 0.7, right? And this is okay, this one has to be 1 minus this one and minus this one. So remember, so you have to make it 100%. Okay, and then okay, so make it 100% because we have to maximize that, and they change the cell for this area. So maximize, and this is what the cell we selected. Okay, and so this is by changing this, right? So we click on solver. Okay, so then you click on keep the solver solution and it's going to change. Okay, that's how the value you got. This is exactly why the value you can get from the textbook. So the textbook, remember you have the alpha, beta, and the gamma. So how the table 10.4, that's how the numbers you got. Okay, so that's I have those formulas in the PowerPoint slide, so you can see. Okay, you sum them up, and then you take once you do that, you see the numbers is already changed. Okay, so the long run variance is omega divided by 1 minus alpha and beta. So you have this is your long run variance. Okay, what is the long run volatility? The long run volatility is the square root of your long run variance. Okay. The long run volatility per year, because the volatility we calculated here is a daily volatility. And then you have to times the square root of 252, you got a long run volatility per year. Okay, this is a per year. So now we finished that GARCH model. Okay, so when you do that, and then you can see the volatility. Okay, so you select the volatility and insert a graph. So let's say we do this one, whatever. Okay, so you can see the volatility. That's the estimate volatility using GARCH 1.1 model. Okay, how the pictures looks like. So that's the volatility. Okay, next, I wanted to introduce is called exponential weighted moving average. So in our textbook is EWMA. The exponential weighted moving average. Okay, let's see, we did GARCH. Okay, so exponential weighted moving average is simpler, okay, because you don't have to, so the weight is going to be lambda, so we only estimate the return of the previous day. Let's see. Okay, so we do here, so we don't need, okay, the silver thing. Okay, so the other thing are the same, so calculate return. Okay, use the relative difference divided by previous day return. And the variance, the first one, you square. And second one, okay, second one, make sure you use the exponential weighted moving average formula. Okay, the one we have is called lambda. We go back to C 1284. So, okay, so you only need one, which is a lambda, okay? And this is a 1 minus lambda to the previous return squared. Okay, so you have this one, and okay, this is the variance lambda and the 1 minus lambda. Okay, and let's go and say we estimate the lambda. Okay, they right. This is the number we need to estimate. Okay, so whatever number we just choose, for example, choosing 0.5. So later on, we're using the solver, so we can solve for that. Okay, the other is you do the likelihood. Okay, similar formula we use for calculate the likelihood, and you sum them up. Okay, you sum all those likelihood, and using solver. Okay, so we go to data. Okay, click on solver. Okay, this solver, you have to set this number, maximize, okay, by changing. Okay, this is the one you need to change is a lambda. So lambda, so whatever the number you put right here, it doesn't matter. And then you set subject to the constraint. So the lambda has to be greater than 0 and less than 1. Okay. And then you click on solve. Okay, you click on OK. So this is the lambda you estimate, 0.9374. Okay, so you already estimate that, and then this is the exponential weighted moving average. Okay, the variance, we take the square root, that's your volatility. Okay, so you get the volatility, insert a graph. Okay, this is how the estimate volatility using exponential weighted moving average. Okay, so you have a homework, which is estimate the foreign exchange. It's quite similar to this type of method we teach today. Okay. Okay, this is the assignment 3A. So it's due by this coming Sunday. Do you have any questions? So I will post the link of the video webinar week 12. So right here, so you will see for the students, if they missed the Zoom meeting, you can come back to watch the video and post 100 words of the synopsis to summarize what you watched from the video. Okay, good. So please open the chat box Okay, open the chat box and type your name for attendance. Okay, any questions? Okay, so if you don't have any questions, I'm gonna stop here and to end the meeting. Okay, see you next Monday, the same time.